few words on analytics. So what if you don't have data and you're just trying to make a decision in an organization without data? Who gets to make the decision? The hippo, the highest paid person's opinion. They are the ones who decide. But I read an Onion article headline yesterday. You guys know about the Onion? And the headline was, business executive is on a roll. He's made 2 logical decisions in a row. Okay. So you can't always count on the hippo, according to the Onion. I'm not supposed to use that as a source. What we prefer are decisions driven by data. Okay, and that is why, with so much data, everyone has to be capable of understanding and analyzing data to a certain extent. We can't rely on the statisticians anymore. And once you've analyzed a data set and you've reached a conclusion, guess what? No one else has done that analysis. It's your job to look at it. So when it comes to answering questions about that data, you're the smartest person in the room. And let's just come full circle. You'll need to be able to stand up, have a nice spiel, mostly memorized, and present that information in a way that people will say, okay, I think that's the correct analysis. I believe those results, and we'll take a decision. We'll make a decision, based on those results of your analyses. And then you get quickly promoted, and you all reach your dreams. One thing you might want to think about, since we're doing VBA in this class as well, if you've performed your analysis in Excel, you might want to think about automating it. So the next time, all the little clicks you made, you just don't have to do it anymore. You just import new data, and press one button, and spit out the results. Maybe not that easy. If you're good, maybe. But automation is always huge and always a big advantage. So when I was an undergrad, I heard this story from my professor. My professor, who was teaching me VBA, said, well, this one student went to ExxonMobil, and they were doing all this stuff in spreadsheets, and it was a lot of manual work, and it took them 3 days. But then my student, who learned VBA, automated it, so it was done, whatever they were doing was done basically instantaneously. And they got promoted, became head of tech for this division, blah, 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 blah. Okay, it's probably true. But, if you can save time, you're saving money, and people will notice that. Okay, you got it? All right. Thank you, Omar. Now I can call you by name. So, I came up with these 5 simple steps for dealing with data. And I called it simple because the steps are simple, and it's basically what I think is the life cycle that I've already mentioned of your data analyses. So first you want to acquire the data, prepare it, analyze it, visualize it, and then sell the results. So let's go over those. So in this class, you'll learn how to acquire data from different sources. So for example, did you know that the SEC has gigs and gigs and gigs and gigs of public data from public companies? And it's right there, ready for your analysis, okay? And did you know all the stock market data from eons ago is on Yahoo? You can download it right to Excel. Also, did you know you can extract data from text? And did you know data.gov, which is basically a site where any public entity can post data, and there's thousands and thousands of databases? And so on. I mean, the internet is full of free data. And you might think, well, in my job, we'll have company data that I need to analyze. But one of the ideas of big data is that your own data isn't the only your own data can be supplemented with other sources, so you can make better decisions, okay? So it's important to gather all the data you need and know how to do it. So here's a cartoon. I'll read to you if you haven't read it already. Don't read it yet. Ah, that didn't work. Okay. So this guy wants Dilbert to check the spreadsheet accuracy, and Dilbert says, "This is an impenetrable jumble of poorly organized data with cryptic labels." And then this guy says, "Well, I only need you to check it for accuracy. Don't worry about the labels." And Dilbert says, "I don't think accuracy matters if no one can tell what it's for." And he says, "Sheesh, this is a simple document. This column is the ratio of product returns to gross revenue excluding sales taxes annualized. It's clearly labeled ROPR, TGR, ESTA. What about the other 80 columns?" Then he gives his report to the boss. What the boop? And Dilbert found no inaccuracies. Okay. So why does this relate to data acquisition? Well, in between the data acquisition step and the next step is this idea of understanding the data. And you're going to get tables with columns you don't know what they mean. And you might think you know what they mean, but you have to think about where the data came from, and you have to look for definitions, data definition documents, if they exist, of the exact meaning of every column in your table, okay? Otherwise, you really don't know what you're analyzing. Okay. So after you get the data, you need to prepare it for analysis, and we'll learn how to do that. So here the pointy hair boss says, use the CRS database to size the market. And Dilbert says, that data is wrong. Then use the SIBS database. That data is also wrong. Can you average them? Sure, I can multiply them too. It's pretty funny. So yeah, that wouldn't help the data preparation. All right, data analysis. So we'll learn different techniques for analyzing the data. We'll begin with learning descriptive statistics, and then we'll touch on statistics and machine learning. So this guy says, do a cost analysis for consolidating our data centers. No matter what the data says, make sure your conclusion is that it's a good investment. Remind me why I went to college? Some liar probably convinced you it was a good investment. So that's the truth about data, is you can massage it and get it to say whatever you want. So you know the famous quote by Mark Twain. It says that there's lies, there's damned lies, and statistics. So be careful about your results. You don't want to be the person that forces the results you want out of the data. Not only will it lead to a bad decision, but someone in the room will be smart enough to question you, and then you'll look foolish, because people will want to know exactly how you arrived at the conclusion you did. So in order to do that, you have to understand the data. If you manipulate the data or prepare it, you have to document how you did that. And then you'll have to be very clear of on your analysis. Once you have results, it helps to visualize them, okay? And visualizations are key to understanding data and communicating the results, okay? I really like this, it's funny. All right. Finally, you want to sell your results. So if you have something useful to say, you don't want to keep it inside, right? You want to let the right people know what's going on in their company, for example. You want to think carefully about how you present your results before you even try to do it, so that you're putting together a coherent story and management can make sense of what you're saying. Once you've presented your results, then you're done. You can give a recommendation, but if you're the boss, you get to decide what to do. If you're not the boss, let the boss decide what to do. And then you'll get credit for all your hard work. And like I said before, you'll be the smartest person in the room in that instant. Okay, so finally, there'll be a big ERP system with data that's been collected for years and years and years. No one's gotten anything useful out of it, potentially. And no one can because they don't know how. But since you'll be a MACCY graduate with the skills, you'll be able to unlock the vault with the mysterious results from these ERP data sets. All right. So you guys ready to get started? You gung-ho? Let's look at some data. Okay, I'm pretty ready too. So I have an assignment for you guys. So here it is. An in-class group project. The first step, this is going to require laptops. So does everyone have a laptop in their group? At least one or two? Okay, you guys have only one? That's enough. Oh, you have one? Okay, yeah, try it out. You guys have two. You guys have two. And you guys have two. Okay, so I want everyone working together. So you're going to go to a website called data.gov. And you're going to download an interesting data set. Okay? So data.gov has data sets about everything from crime statistics to flight accidents to unemployment numbers and so on. But, at this point, I need to stop you and we need to think about something. I want you to download an interesting data set, but a lot of times this is where you could run into issues right away. There's problems. Problems with the data, problems with the download, I don't know. So what do you guys anticipate could happen when working with the data? What are you guys' ideas? Yeah, any issues, problems? Okay, so if you have like a huge data set and it just won't open in your tiny computer or in Excel. Okay. And I've seen that. Yeah.
Maybe compatibility issues depending on what type of file is it.
What'd you say?
Compatibility issues. Like maybe
Oh, compatibility issues? Yeah.
it's not like in an Excel Word document with software that I don't have.
Yeah, so I mean the next step I have is open in Excel, and let's say, like you said, maybe it's a text file, maybe it's a PDF, and those exist on this website. So compatibility issues be one, yeah. Yeah, so let's say you pick a topic, unemployment in New Jersey. And let's say there are 100 columns. Well, you got to know what each of the columns mean before you can do any sort of analysis. Yeah, absolutely. You had your hand up?
Yeah, I was going to say maybe like if you're looking for a certain thing, but then you find data and you think that's the exact thing, but it's like slightly different, so it's not the exact results that you wanted. Or it could be like skew your opinion one way when it's not like all the information, or you don't have all the it's not exactly what you're looking for.
Yeah, so I mean that happens a lot. So it's doing a perfect analysis is like never happens, almost, right? And that's because partially because you never have perfect data. And it could be that, like you said, I don't know what an example is, and I can't think of one off the top of my head, but just having data that doesn't quite match what you're looking for in order to answer the question you want to answer. Sometimes in research, we always have proxies for the measure we want. You can't get the best measure, You can't measure exactly what someone's thinking, so you have a survey. Okay. So that's a good point. Someone over here?
Yeah, it's basically just sometimes it's bias. Making sure changes because
Yeah, so two things I thought of. So I think you said. So one point is people can manipulate the data. They can change the numbers in the databases that are going to be analyzed. So you have to be very sure about your source, right? And the potential for manipulation. And then you can also skew things based on, like you said, units of measurement or how you present the results to make things look really bad or really good. Like if you have a long flat line across time, and I'm not sure if this is what you were saying, but if you just do a little technique to squeeze the graph a little, and now it's goes straight up. That's kind of funny. Okay.
I was going to talk about the accuracy. I know this is a government website, but for example, in Egypt, I've done a lot of research for work and for school. A lot of the government agencies themselves would manipulate the data. So for example, we have something called CAPMAS, where they work with all the statistics and like population and growth and accidents and all that, and instead of giving us the raw data itself, they would ask us specifically what we wanted from this data, so they can give us a good result instead of the truth. But it's always difficult to know the accuracy of the data itself.
There were reports. I used to live in Tucson when I was at the University of Arizona, and that's 60 miles from the border, and we did work with the Border Patrol in my PhD program. Anyway, so I met with Border Patrol. I even got to come up to New York and go to the St. Lawrence River and meet the Border Patrol, for Canada, because we don't want the Canucks, coming in here. Anyway, so after I came here to Rutgers, so our former governor of Arizona, Janet Napolitano, was the head of the Department of Homeland Security. Anyway, I'm not implicating her or anything, but anyway, there were reports from the sheriffs down to the border that they were trying to lower what seemed to be the number of immigrants coming across the border. So the way they measure that is by the number apprehended. Well, if an immigrant crosses the border and you yell at him and scare at him and shake your guns, I don't know that they did that, and they run back across, then they never crossed because they were never apprehended. So normally, this could be a technique to just have people have a false view of reality, like you're mentioning the same thing in Egypt. And this was purported to have happened, but I wasn't there to witness it. Do I believe it happened? Yeah, probably. There's all kinds of screwy stuff going on. Go ahead.
I'm thinking maybe the time frame that you're looking for is not available. Maybe it might be outdated.
Yeah, exactly. Yep. So you want to know the situation now, but all I have is pre-recession data or something like that, or up to 2010. Good point. Anyone else? Mark.
I know like certain times people will try and like take a certain data set and like predict the future from that and like extrapolate it out, even though like it's not valid. Like kind of like what you were saying, like if it's before the recession, you can't like take those numbers and extend them out 10 years because it won't work out right. You have to like know the whole situation that's going on if the climate is stayed the same regarding the data.
Yeah, extrapolation is, we're always trying to predict the future. And we try to do that by looking at the past because we still don't have a way of looking into the future. And so you have to be careful about extrapolating. There's a book called Fortune Sellers. Have you guys read it? It's basically about this phenomenon where people make money by forecasting about the future. So they call them fortune sellers because they make money. And, I can't remember all of the cases, but one of the areas where we're actually good at predicting, better than chance, is the weather. So actually we're pretty good at predicting the weather a few days ahead of time. So sometimes when you want to know, well, how good are we? Well, what's the baseline measure, do you think, for predicting the weather? What would you compare yourself against? What's like the worst you could do without having any information? What would your prediction be for the weather tomorrow? How would you know? Just
Similar to today.
yeah, similar to today. That's the baseline. There's always a baseline for something. There's something to compare. You try to anyway to see how accurate you can be. So the best way to predict the weather used to be compare. I'm guessing the weather tomorrow is going to be like the weather today. Okay, but now we're better than that because of all the data we have and the satellites and our understanding of air currents and things I don't understand. Anyone else? So, yeah, okay.
One more thing, to build off of what Mark said, I think comparability of data, right? If you change underlying assumptions for more predictable data, kind of undermines the whole purpose of the data.
Sure. Yeah, if you're comparing data, even if this, you have to be very careful also. If you're looking at data sets from two different sources, you have to normalize it as best as possible to make any sort of comparison. Yeah, you have to be careful about comparisons. Sometimes there's missing data, and that'll ruin your results. So if you might find in a column that you have blanks, or you have something like null or NA or something like that. So you have to figure out, you have to make sure you're handling that properly. Sometimes you want to fill in those blanks. You have to in order to do your analysis. And maybe you use some sort of average of everything else and just stick it in. But like I said, there's no perfect data set. Maybe you can ignore them. I don't know. It depends what you're doing. You have to handle that. Yeah. Anything else? Oh, sure.
Sometimes we look at, I noticed on the website, sometimes we look at the data, they're slightly like off, or ups and downs. You wonder if they made an error or like something going on. It's like consider like some sectors positive number and then it's like high like negative number. You wonder what's going on. Maybe they just made a mistake.
Mm-hmm. Yeah, there's errors in the data, right? And sometimes they're manual, and sometimes they're generated by the machine.
Or more likely, like you just want to find out what's going on that year that caused this number.
So there was this one weather station, or it wasn't a weather station, I don't know, but it was a location where we recorded the daily weather, and they found out it was next to an air conditioning unit. And what does an air conditioning unit do? Well, it cools things down in the house, but it spits out heat. So it would mess up the results, right? And you wouldn't say it wasn't a human error necessarily, but it definitely would change the results. Okay. Okay, Ashley.
I just wanted to say something more or less what Mark was saying before, that if you know what you're trying to find data for, say, open a database, look at it, and it's not really what you want, you're like, oh, I can make this work, like I can just kind of put this into the results I'm looking for, but not necessarily what you expect it to be, but you just kind of take what's given because you don't think you're going to find anything else. So just take the data that you have.
Make it work. Yeah. So you have to, sometimes that's all you can do. But the key is disclosure. let everyone know what you did. You know, if your boss says do this and that, say, well, you know what, I couldn't do exactly what you said. There's no data, so I found the next best thing. That could be a good thing. But just be open and just let the data speak for itself. All right. Good discussion, guys. You brought up a lot of good points. The key is, like I said, when I listen to your presentation and especially the group presentation, and you're using data I haven't seen before, you want to anticipate the types of questions people are going to ask about the data. I've seen a lot of data. I kind of know how to manipulate it. I know what the pitfalls are and the problems people have. So in your group presentation, hopefully you'll be seasoned enough to give an accurate representation of what you've done. Okay. You know, when you're trying to get a job, sometimes they ask for writing samples, right? I don't know if you guys have to do writing samples, but a writing sample for like law school or PhD program, why do they ask for a writing sample? Because it's like a really quick way to see how well someone can, how smart someone is, how well they can form an argument, how well they can put words together. And these presentations are like writing samples because you're going to create a story out of nothing. You know, you've done your own analysis, you've picked your own data set, you're going to create a story out of nothing, and you need to create a story that makes sense to the reader. And it's got to be very precise. And no blathering about things that the data doesn't say. Okay, just stick to what the data tells you. You can, if you want to say something that the data could mean, then just let people know this is what we think this might mean. You know, don't be very firm about it. If it is what the data says, you can be more firm about it. Okay. So in this project, you're going to download an interesting data set. You're going to choose one as a group, open it as an Excel spreadsheet, take time to understand the fields and columns in the data. Now what you'll find is you have a huge data set you've identified and you don't have time to understand everything. So pick something, pick the ones at the beginning of the spreadsheet are usually the most interesting ones. Then think about what questions you want to answer from the data. So formulate some questions, and this is kind of narrowing the scope. So you can't worry about all the data. Just pick a few interesting questions, and then use Excel to analyze the data and answer those questions. After you've done that, create visualizations to show your analysis. Then create a 5-minute PowerPoint presentation on your findings. If applicable, include relevant recommendations and any difficulties or kind of like lessons learned from the process. So go ahead and so this is how the rest of class will work today. So at 12 o'clock we'll take a lunch break, and I guess I didn't consult you guys, but usually what the students prefer is a half-hour lunch break, and then you get out a half hour early instead of an hour lunch break, and you get out at 3. Usually every year they just want to get out at 2:30, but is there anyone who would prefer an hour lunch break? Everyone would prefer a half-hour lunch break. Okay, so at 12 o'clock we'll have a lunch break, and then at 12:30 you will resume the exercise. So at this point I'm going to leave it in your guys' hands. So you'll encounter difficulties, problems, whatever. So solve them yourselves as much as possible. Okay. And any questions? No? All right, so get started.